Okay, so we are on our second step here, the elimination process. So again, our main idea, and this is the part that comes into play the most with the elimination method, is creating these additive inverses in front of one of the variables that we find. So if we're working with an instance where we have two variables that have x and y in them, which is fine, then we need to try and eliminate either both of the x's or both of the y's. And the additive inverse is going to be really helpful in doing that when we get to our third and fourth steps here. So the additive inverse, by its definition, has a number value that is the same. So we have a couple examples here with it. The number is the same, but the signs are different from one another. So our couple examples that we have here, we have a -7, +7. +5, -5. 1/2, -1/2, -5/3, and 5/3. So again, the signs are different, but the value is the same. Once we've done that, we're going to add the new equations together vertically to eliminate one of the variables. And this is where we're going to use the additive inverse coefficients to cancel those things out. One of the variables will cancel. We'll get the other one that we solve for, y equals something, x equals something, whichever one we didn't eliminate. And then we're going to substitute the value that we found in step 3 in for that respective variable in one of the original equations that's been given to us. And then we solve for that remaining variable and we find our answer. From there, check that ordered pair in both original equations, just like we did with our substitution method. And then we're good to go from there. So there is an alternative method that you can use to find the additive inverses that I will show you guys with these examples, but I do think there are some pitfalls with it that I would recommend going away from if you can avoid using this alternative method. There's nothing wrong with it, but I have seen many errors show up with it in total. Okay. So these are our two examples that we are going to work with right here. And I'm going to jump us over to our whiteboard and we're going to go through how to do these things. Again, if you guys have your notes, it'd be worth taking out as well. Again, I'm going to apologize for this now, but I'm going to step out here for a quick minute again. Stomach is not getting any better. So I'll jump us over to our whiteboard, but I will, again, I'm sorry, apologies for having to do this, but I will pause the recording, and then when I come back, we'll go through some of these examples. Yeah, I'll be right back again. Sorry. Okay, so we're going to go through the two examples that are listed on the lecture notes. So our first example that we've been given, we're working with solving for our first equation and our second equation. Now, I would recommend to everyone, as you're going through these for the first time, if you are in that boat, if you've not used the elimination method, I'd highly recommend with all of these systems of equations, always write out the actual system you're working with, label them as equation 1 and 2, and keep them somewhere safe on the pages wherever you're not going to edit them. We are going to be rewriting at least one of these, but we want the originals written down somewhere for ourselves. Yeah. So at this point in time, from here, we're going to follow our process. Our first step in this, rewrite both equations into general form, aka standard form, and that's in that ax plus by equals c form. So equation 2 is already written like that. We have the ax on the left side, which should get a number in there, plus by equals c. So all of the constants are on one side, and all of the variable terms are on the other side. We need to do that for equation 1, though, because that currently is not in our standard form. So doing that, we need to rewrite this thing. Again, all the variables on one side, all the constants on the other. So I'm going to subtract 2y from both sides. To get to that there. So I've just rewritten my first equation to now be in standard form. Now I'm going to write both of the equations right next to each other. Again, we want to have those also aligned vertically. It's going to be really helpful down the road here. So we have our rewritten equation here, that 3x minus 2y equals 5. Our other equation, 9x plus 4y, is equal to negative 10, like this. And again, we still have our equation 1 and equation 2. So again, that was our first step. We rewrote both equations into general form if they weren't already in that, which is what we have now. Make sure when you're writing these things out, make sure you have the x terms aligned vertically, the y terms aligned vertically, and the constant terms on the other side also aligned vertically. It's going to be really helpful for our second and third steps with this. Now our second step, multiply one or both of the equations by a constant, so both equations have one variable with coefficients that are additive inverses. So the goal is you want to choose and basically tell ourselves, okay, we want to eliminate the x values or the y values. And the way we do that is, again, by modifying one of these things to have, or both of them maybe, to have additive inverses. The value is the same, but the signs are different. And again, we can choose x, we can choose y, it does not matter. So for this instance, I'm looking at the y variables that I have here, and I'm noticing, okay, both are y's, one is positive and one is negative. So I already have half of the additive inverse part of things taken care of for me, which is great. But now I need to figure out how am I going to make the number value be the exact same as well. One of them is a negative 2 on top, the other is a positive 4 on the bottom. So the way I'm going to create these additive inverse, as it were, I'm going to take my first equation, so equation 1, and I'm going to multiply everything in it by 2. We'll get to why we're going to have or use 2 here in our result. So every single term in equation 1 is going to be multiplied by 2. It's going to give me 6x, oops, better x, minus 4y is equal to 10. And our second equation, nothing is happening to that one. We're just leaving that one as it is. So now we can see that with our y variables, I now have additive inverses as the coefficients. They are the same value, but they have opposite signs from one another, which is the main thing that we need to do for step 2. And that's where I think step 2 with doing this, determining what the additive inverse is going to be and all that, I think that's the trickiest part with this process, at least in my opinion. It could be something else for you or anything like that, but I think that's the hardest part, is figuring out what that's going to be. So from here, now in our step 3, add the new equations together vertically to eliminate one variable, the one with the additive inverse coefficients. Okay? So what that looks like is it means everything down here, my second equation, is going to add together. And again, you are adding vertically. Add the x's together, add the y's together, add the constants together, and we see what we get. So I have 6x plus 9x. It's going to be 15x. Negative 4y plus 4y, it's going to give me 0y. And if you would like to, you can write in 0y, but because it's just going to be 0, we don't actually need to write anything. I've seen some people like to cross that out as they cancel. You're welcome to do that, whatever works best for you. All we know is that we should have no y's showing up in our answer here. And then we have a 10 minus, positive 10 minus 10. Okay, well, that's just going to be 0. So now I have 15x is equal to 0. divide by 15 on both sides. We get 0. So that was step 3 in our process. So now we have one of our variables. We have x equals 0. Step 4 is telling us substitute the value found in step 3 in for that respective variable in one of the original equations given to us. So it doesn't matter which one we choose. Just need to pick one and move forward with it. If any of you were predicting that was what I was going to say, congratulations. You're one step closer to being able to read minds. So I'm going to choose, why not? I'll choose the second equation. Just moving us back up here. So I'm going to use the second equation to find my y value. So again, write out the equation first. We've got 9x plus 4y is equal to negative 10, better x. There we go. And again, we found our x value, so I'm just substituting 0 in for x in this problem, for this equation, plus 4y is equal to negative 10. 9 times 0 is just going to be 0. I now have 4y equals negative 10. Divide both sides by 4. And I'm getting y is equal to negative 10 over 4. We have a fraction answer, which means we always need to ask ourselves, can I reduce this fraction down? And this one, yes, we can. We can reduce this down to negative 5 over 2. So we have that there. And our final answer, because we need it written as an ordered pair, final answer is going to be 0, negative 5 over 2. And again, optionally, to check our answers, or our answer that we have, we can plug in that ordered pair into one or both, we want to do both, of the original equations. So our check is going to be the exact same thing that we did with the 5.1 and 5.2 material with how we check our answers. So we take a look at our first example that we did in 5.2. I believe that's the one where I checked our work. But we're going to do that exact same process here with the elimination method if you are going to check your answers. So I'm going to move us up here. I'm going to go on and take a look at example 2. Zoom this out here a little bit so I can divide this up a bit better. There we go. Okay, so example 2 has us, what's this doing? There we go. So again, example 2, we're doing the exact same thing, except we're going to have some fractions showing up in here. We have to figure out how we're going to work with those fractions. So our first equation, let's switch ever so slightly. Second equation. All right, making sure I wrote this thing down correctly. All right, so we have x over 6 plus y over 9 is equal to 2. We got that. X over 8 minus y over 3 equals 9. Okay, so we're good to go there. So we have our two original equations. Now again, we want these things to be in standard form. That's ax plus by is equal to c. And we want a, b, and c to be integers. Essentially, we don't want any fractions showing up in here. So the question becomes, how do we eliminate these fractions? We're actually going to use the method that we used all the way back in, chapter 2, I think it was, solving equations with fractions showing up in there. So what we're going to do is we're going to take each equation and we're going to multiply them by their respective lowest common denominator for all the terms. Again, very similar to what we've done in the past with eliminating fractions, but we're doing the exact same thing here now. So I need to determine what is the lowest common denominator for equation 1 and what is the lowest common denominator for equation 2. And for equation 1, it's going to be 18. For equation 2, it's going to be, I believe it's 24 for that. Now, I'm going to take my first equation and I'm going to multiply every single term by that lowest common denominator. I'm going to do the exact same thing for the second term as well, except I'm going to multiply it by 24 instead. So if you want to make a note to this off the side for yourself, I generally like doing something like this. Equation 1 times 18. Or equation 2 times 24. So make a note to yourself somewhere of what you're doing, and then we go through and make that happen. So x over 6 times 18, that's going to give me 3x, looking at our first equation, plus y over 9 times 18, well, that's going to be the same as 2y, is equal to, and then 18 times 2 is going to give me 36. So I've just modified my first equation is all. Looking at a second equation, so I'm doing x over 8 multiplied by 24. That's going to also give me 3x minus y over 3 times 24, which is going to give me 8y, is equal to 9 times 24, which I don't know what that number is off the top of my head. So I'm going to apply the calculator. I'm going to do 9 times 24. That's going to give me 216. So now I have my new system of equations, but all the fractions are gone. And now I can work with this just like I did with the previous example that we went through. I can find an additive inverse and multiply these things, or add them together, and then eliminate a fraction, or a variable, I should say. So looking at this, we can eliminate the x's or we can eliminate the y's. The x's already have the same value. We just need one of them to have opposite signs. If we look at the y's, we see, okay, well, I could multiply that 2 in the first equation, right here. I can multiply that by 4, or use the entire equation by 4. So that way, these two things are going to be additive inverses, a positive 8 and a negative 8. And either option that you choose to use will absolutely work. It's your call. We solved for x last time, so for this instance, let's eliminate x. So what I'm going to do, I'm seeing the 3x in the first equation. I'm seeing 3x in the second equation. I need one of them to be positive, one of them to be negative. Does not matter which one we choose. Just got to pick one and move forward with it. So I'm going to elect to change the first equation to being a negative 1. So the way I'm going to do that is I'm taking the first equation and I'm multiplying every single term by negative 1. Again, I do not change this problem if I multiply every single term within it by that negative 1. But we need to do that so we can create additive inverses. So with that negative 1 distributing through, you could put air quotes around that distributing through if you wanted to, I'm going to get negative 3x minus 2y equals negative 36. So all that changed was I did my first equation, multiplying everything by negative 1. Nothing changes in our second equation. It stays exactly as it was. And now I'm going to add these equations together vertically. So negative 3x plus 3x, those are going to cancel and be gone. I have a negative 2y minus 8y. That's going to give me negative 10y. And then I have negative 36 plus 216. I don't know what that is off the top of my head. I want to guess 180. It is 180. So I just applied the calculator off screen. Again, just adding vertically with each of these things. And if you want to, you need to. Again, those parts cancel. If you want to cross those out for yourself, you're welcome to do that. If in the line below where we would have a spot, you could write in 0x if you wanted to, but it's not necessary because we're not going to actually do anything with it. And now from here, oh, there it goes. And now from here, I want to get y by itself, so I'm dividing both sides by -10. And we get y is equal to -18. So we have our y value. Fantastic. Now we need to solve for our x value. Move this up here. The way we do that, again, following our process, we substitute the value that we just found. It's y equals -18. We substitute that in for y in either of our two original equations. Doesn't matter which one, you just got to pick one and move forward with it. I think we used equation 2 in our previous example, so I'm going to use equation 1 for this one. So again, I recommend when you are doing this, write out the original equation, I should say. And then in your next line of work, then write in the substituted value, or the previously found value, I should say. So we've got that there. And now we're just going to simplify this thing down, and we're going to be solving for x. Okay. Oh, it's -18. Should probably put that in correctly. Thought something looked off with that. Come on, there we go. So again, make sure you're, oh, if I can get that part right too. So we're plugging in that value and its sign there. Don't make my mistake. Make sure you have the negative attached to it as necessary. It should be -18 right there. Then as we simplify it down, we're getting -2. Again, I'm solving for x, so I want everything else to be on the opposite side of this equation. So I'm adding 2 to both sides. I'm getting, should I move this out of the way? There we go. So I'm getting x over 6 is equal to 4. I want to get rid of that 6. It is attached to the x through division. I undo division with multiplication, which means I'm going to multiply everything on both sides by 6. On the left side, I'm just left over with x. On the right side, I have a 24 remaining. So there's my other part of this ordered pair. Bring it all together as one single ordered pair for the final answer. We should have 24, -18. For our final answer to this problem. So this is going through and solving this thing, or solving these types of problems using the elimination method. Now I did make a note in the, I'm trying to refind my notes here. So our method that we are using with this was to find the additive inverses. And we did that in, do this in yellow here. And we did that in a step right here to find the additive inverse. We used this process right here. Again, to find additive inverses for one of the variables. We did that there. And then in our first example, we did that right here. There's nothing wrong with doing it this way. Now I am going to show you guys an alternate method that you can use where you aren't using the additive inverse in all of these problems that we're working with. And I'm going to draw from this example that we're at right here with number 2, because I think it's already pretty much readily available for us. So the alternative method, I'll show this to you guys as we get to it. We still are going to start off doing the exact same thing. Oh gosh, What is the whiteboard doing to me now? Technology is not designed to cooperate today. Okay, there it goes. So we're going to start off the exact same way as we did previously. I want to get rid of these fractions, so find the lowest common denominator and multiply each of those things respectively by the lowest common denominator. Fractions are now gone, and we are at this step. So this is where I'm going to jump us farther below to an alternative method to solve this thing. Come on, there we go. So our first equation, I have to go back and forth here just to make sure I'm tracking it correctly. 3x plus 2y is 36. So I'm just rewriting those down below here. Okay. And the other one was 3x minus 8y, 216. Okay. Okay. Make sure we have that in correctly. Yeah. So I'm just going to label this really quick as again, it's alternative method that you guys are welcome to use here. So at this point in time, with how we went through this problem originally, we went through and found the additive inverse for both of these things. Again, the same value, different sign, and then eliminated one of the variables. That was our base method that we use. The alternative method is to say, I'm not going to find additive inverses. I am just going to find out and multiply things accordingly so that way I can have these variables be the exact same to one another. So in our previous one, I wrote that in wrong. It should be a minus 8 down below here. So our previous example, we went through and made the additive inverse for these problems. So we made the x values, additive inverses for the coefficients, and then we would add them together. So this method instead says, instead of finding the additive inverse, make the coefficients between one of the variables the exact same. Make the value and the sign identical to one another, which is what we have right here in our setup. So we have 3x and a 3x, so the exact same values with the exact same variables. Now this alternative method has us, instead of adding these things together, we're actually going to subtract vertically. So again, when you are doing this, if you're using this method, write this out for yourself. And I'll show you guys and highlight the issue that shows up with using this method. This is why I would advise caution with it. So in our other examples, we went through and we said, okay, I'm going to add vertically. In this instance, if you have the coefficients to be the exact same value, you are instead going to subtract vertically. Now, what's really nice about this is we see for ourselves 3x minus 3x, and then we're good to go. Those are going to cancel. We're going to get 0x coming out of it. Now our next one, here's where the errors start showing up. And this is what it's a very, very common mistake. But this is why I want to note it now. Looking at the y's that we have here, a lot of people will completely forget that we have a negative out front. And they will simply do 2y minus 8y, which is going to give us negative 6y. And then they go ahead and from there, do 36 plus 216, and I believe that's going to give us 252. Which again, not correct, because we have this negative out front. So what we really should be doing with this is, if you are going to use subtraction, you need to take it really, really slow, because what we are really doing is we are doing negative, or we have a positive 2y minus negative 8y. Negative and a negative makes a positive, so I should be getting 10y out of that. 36 minus 216 is going to give me a negative 180. And then from here, 10y equals negative 180. Divide both sides by 10. And we'd find y is equal to negative 18. And then we can go through and going through the rest of the process, we would find, again, x to be 24. We get the same answer either way. But again, the big part that I want to emphasize with this, if you are not going to find the additive inverses for a variable, and instead set the coefficients to be the exact same value, like we have right here, there is nothing wrong with that. If you're going to use that and then subtract these things, nothing wrong with doing that. But make sure that you are accounting for not just this being subtraction, top minus bottom, but also this is subtraction, top minus bottom, and this is subtraction. So this is where, for me personally, I do not like using this method, because you basically need to go from here is your starting point, minus, and then something else. So you have to basically go in this order for keeping track of things. I think it's one extra step that is not really too fun to keep track of, in my opinion, but it will work all the same if you would like to use and solve these things out this way. So this is the alternative method, and I do have it noted in the process that we have as well. But I want to at least give you guys an example, numerical example of what this looks like. So again, on the homework or on the test, if you are asked to solve using the elimination method, either of these two methods will work. You can either find additive inverses and add vertically, or make them the coefficients the exact same and subtract vertically. Either one works. It's your call on which one you would like to use. Now I'm going to jump us back to our notes here, because there's one last bit that we do need to touch base on with this. So we can have the instances like we had yesterday, where what if we're going through and using the elimination method, and we find that we get a number is equal to a number. Well, what happens there? Well, that means that these lines are identical to one another, so we have infinite solutions. So just like yesterday when we went through 5.2, using the substitution method, we can have an instance where we have infinite solutions. We can also have the instance where we have no solutions, which is we go through the elimination method process and we find a number equals a completely different number, which is impossible. That tells us the lines are parallel, they will never cross, and we have no solution. So just like yesterday, put us over to our 5.2 notes. We can have the exact same thing showing up for our potential answers. And all that the elimination method is just a different process to go through and solve these things. Okay? So that is everything for the 5.3 material. Again, this is a very, very mechanical process to go through. I think it's really nice in that regard. But that's everything that we have for this. So I'm going to end our screen share here. I'm going to step out here really quick again. Something's still giving me some issues. And then once I'm back, we will get going on the rest of the material, basically. Or I'll take any homework questions that you guys have, and we'll go from there.